So thus far we've talked about synthesis reactions and decomposition reactions. And the next type of reaction we're going to talk about is single replacement reactions. And so what happens in a single replacement reaction is you have a compound and another element comes along and kicks out one of the elements in that compound. So imagine two people are dancing and you have someone come in, kick one of the partners out, and now you've got a new compound and a new element all by itself. So here are some of the rules for you to keep in mind when we're talking about single replacement reactions. The first one is that the positive ion, also called the cation, is going to switch with another positively charged ion. So the atom that comes along to kick out a partner, if it tends to have a positive charge when it is an ion, it will kick out another positively charged ion. If the atom that comes along is negatively charged when it's an ion, it's going to switch with a negative ion. Okay, so positive kicks out positive, negative kicks out negative. And when we're writing a compound, remember you always put the cation first. All right, and finally, in order for an element to kick out another element, it has to be higher on the activity series. If it's not higher on the activity series, it will not kick it out. All right, so let's look at some examples. I've got magnesium, and magnesium is going to go and it's going to try and kick out either silver or chloride. And so we got to figure out which one it's going to try and kick out. Well, magnesium, when it's an ion, is positively charged, which means that magnesium is going to try and kick out silver because silver is also positively charged. So magnesium goes in, and if we look at the activity series, which is in your workbook, we'll look at it more in class. Magnesium is higher on the activity series than silver is. So magnesium will go in, it's going to kick silver out, and it's going to form a new compound with chlorine. In order to write that new compound, I've got to cross my charges. So magnesium and chlorine cross my charges, I get MgCl2, and silver is now by itself because it got kicked out. And the last thing I've got to do is balance, so I'm going to put a 2 in front of AgCl and then a 2 in front of Ag, and I'm done. Okay? If we look at the next example, bromine's going to go in, and it's either going to try and kick out Na or I. Well, bromine, when it's an ion, has a negative charge, which means it's going to kick out the negatively charged ion in that compound, which is iodide. So Br is going to go in, kick out I. So Na and Br are now going to be partners, and iodine is going to be by itself. Now, iodine is diatomic, so it's going to be I2. All right? Now I've just got a balance with a 2 and a 2. And that's it. All right? Another name for single replacement reactions is oxidation reduction reactions. So what exactly are those? Well, reduction means the gain of electrons, while oxidation is the loss of electrons. An easy way of remembering that is oil rig. So if you think about it, if an element is oxidized, that means it loses electrons, so its charge is going to become more positive. If an element is reduced because it's gaining electrons, it's going to become more negatively charged. So in order to understand what's being oxidized and what's reduced, in order to understand charge, we need to talk about oxidation numbers. Okay? And so oxidation numbers are simply a way of keeping track of electrons that are gained or lost. So here are some basic rules. And what you'll find is that for a lot of the basic elements, oxidation numbers are very similar to charge, which you've already learned. So, elements, atoms that are by themselves, they have no charge, and also their oxidation number is 0. Okay? The sum of all the oxidation numbers of compounds, if you think about the charge of an entire compound, that's also 0. Okay? And the sum of the oxidation numbers for polyatomic ions, that's going to be the same as their charge. So for example, NO3, the sum of all the oxidation numbers for nitrogen and oxygen in there is going to be -1. All right? Oxygen normally has a -2 oxidation number, just like its charge, except when it's peroxide. Okay? If it exists as O2 in a compound, its oxidation number is going to be -1. All right? When hydrogen is bound to nonmetals, remember nonmetals have a negative charge, hydrogen is going to have a +1 charge. When it's bound to metals, which have a positive charge, it's going to have a -1 charge. Okay? Fluorine is always going to have an oxidation number of -1, which is the same as its charge. Other halogens tend to have a -1 oxidation number, just like their charge. Okay? But when they're combined with oxygen, because oxygen always has that -2 oxidation number, except when they're peroxides, then halogens can have various oxidation states, which we'll look at. Okay? The easy stuff, group 1 metals always have a +1 oxidation number, just like charge, and group 2 always have a +2 oxidation number. All right? And the positive charge generally comes first when you're writing a compound. So, with these rules in mind, let's look at a couple of examples. So here's what I always do. I start on the far right, I then go to the far left, and then I deal with the middle. So, oxygen. Oxygen always has a -2 oxidation number, just like its charge. And that's what you would write if someone said, what's the oxidation number of oxygen? However, because there are 4 oxygens, the overall oxidation number is going to be -8. Okay? Potassium, I'm going to go over to the left side now. Potassium has a +1 oxidation number, just like its charge. And so what I've got to figure out now is manganese's oxidation number. Well, potassium contributes +1, oxygen contributes -8. Remember, that entire compound is not going to have an overall oxidation number. So manganese must have an oxidation number of +7. Okay? So if I were asked, potassium has a +1 oxidation number, manganese +7, oxygen -2. Let's look at one more example. So this is carbonate with a 2- charge. So again, I'm going to look at oxygen first. So oxygen has a -2 oxidation number. Since there are 3 of them, it's going to be a total of -6. And when I'm trying to figure out carbon, keep in mind that the overall oxidation number of this ion is -2, which means that carbon, it can't have +6 because that would give it no overall oxidation number. It's going to be +4. All right? So this concept seems a little out of place with what we were talking about with single replacement reactions. But in order to determine what's reduced and what's oxidized in a reaction, we've got to know oxidation numbers. And then we can use oil rig to figure out what's oxidized and what's reduced. Notice this reaction right here, this is a single replacement reaction. So let's figure out oxidation numbers. Lithium is an atom by itself, so its oxidation number is 0. Okay? Oxygen has an oxidation number of -2, but because there are 4 of them, it contributes -8. I'm going to go to the left-hand side now. Sodium, Na, has a +1 oxidation number, but there are 2 of them, so it's +2. Remember, the overall charge of this is 0, overall oxidation number, so sulfur must have a +6 oxidation number. Okay, so sodium's +1, sulfur +6, oxygen -2. I look on my product side, sodium has a 0 oxidation number. Then I'm going to go, when I'm looking at lithium sulfate, remember you do oxygen, then go over to lithium, and then go back to your middle. So oxygen is -2. There are 4 of them, so that would be -8. Lithium has an oxidation number of +1. There are 2 of them, so that would be +2. And so sulfur would be +6. So with all of these oxidation numbers, I can now determine what is being oxidized and what is being reduced. Well, if you look, lithium goes from an oxidation number of 0 to +1. So that's a change. So it's either going to be oxidized or reduced. Okay? And sodium goes from +1 to 0. Okay? So if sodium's going from +1 to 0, if you think about that, that means that it is gaining electrons because it's going from positive oxidation number to 0 oxidation number. So if it's gaining, remember, oil rig, oxidation is loss, reduction is gain. So sodium is being reduced. Lithium goes from 0 to +1, which means it is losing electrons, which means that it is oxidized.